Hey everyone, today is Unit 12, Day 12. It is Friday, April 17th, 2020. I put this meme over here because it is my 30th birthday tomorrow, which I'll be spending in quarantine. Yay! Um, so at least it's on a Saturday, even though that doesn't really mean anything anymore. So I'll be hanging out in my sweats watching TV again. Please take out Unit 12, Kinetics and Equilibrium Note Packet. Today we're going to continue learning about Lechatlier's principle. And when you're done, you're going to complete Unit 12, Day 12 Skill Check. I know Lechatlier is really confusing, so I thought what we would do is we do a warm-up based on kind of what we did yesterday. So you can do this on the top of your note packet. You can do it on any kind of blank sheet of paper, whatever you'd like. But from yesterday, remember, when you add something, your arrow shifts away. And when you take away something, your arrow shifts towards what you took away. So I kind of wanted to do the warm-up problem using this reaction. You've got CH4 plus 2O2 with a double-sided arrow yielding carbon dioxide and 2 moles of water. And it says, if I add CH4, what way does the system shift? Does it shift left or does it shift right? So remember when we do these, we're going to either put a plus or a minus sign over the substance. Now this says we're adding CH4. So I'm going to put a plus sign over the CH4 because I'm adding CH4. Remember, if you add something, you shift away. So that means I'm going to draw a new arrow over my old arrow that is shifting away from this plus sign. So it's going to shift away from that plus, which is to the right. So that is a right shift. So what's going to happen to the concentration of carbon dioxide, which is right here, because I am now shifting this way? I'm right shifting, which means I'm using up more of these to create more of this. Well, remember, the arrow you draw points towards the substances that increase in concentrations. This means that carbon dioxide is going to increase in concentration. What does that mean for oxygen, O2, which is over here? Well, this new arrow we drew doesn't point at that oxygen. It points away from it. So that means this is being used up to create more carbon dioxide and water. So the concentration of that O2 is going to go down. So that is kind of what we did yesterday. And we looked at how increasing or decreasing concentrations affects an equilibrium. Does it shift left? Does it shift right? What does that do to the concentrations of things when that happens? Now today what we're going to do is we're going to look at the second and third stress. We're going to look at temperature and we're going to look at pressure. The good thing about temperature is it has the same rule, add away, take towards. So if you could, please take your notes out to page 13. We did kind of the first half of page 13 where we looked at concentration. Now we're going to be looking at temperature. And concentration and temperature have the same kind of rule to help you figure out which way it shifts. So remember, add, away, take, towards. So the same rule is going to apply for temperature if I increase or decrease temperature. So as yesterday, we are going to do an increase first, and then we'll do a decrease as a kind of example. So this is our second stress, which is temperature. So if we increase temperature, right, increases like plus, like adding, the reaction is going to shift away from the reaction side that contains the heat. So unlike the reaction from yesterday, you're going to notice that this reaction now has heat in there. So we now have heat in the formula. But the rule applies, add away, take towards. So let's look at this example. If we add heat to the system, what's going to happen? So instead of putting a plus or a minus under the actual chemical formulas, we're adding heat. So here's heat. So I'm going to add heat. So I'm going to put a plus sign on top or the bottom of heat. I'm adding heat. Now I got to figure out which way my arrow is going to shift. So here's my original arrow. If I add, my new arrow needs to point away from what I added. So that means my new arrow needs to point towards the left. So that means I shifted towards the left. And how I can kind of read that now is that NO and H2O are being used up to generate more of NH3 and O2. And remember, the arrow you draw points at the substances that now increase in concentration. So this says which substances concentration would increase? That would be the NH3 and the O2. Which concentrations would decrease? That would be the substances whose the arrow is not pointing at. That would be the NO and the H2O. Because remember, when I shift to the left, I'm using up more product to create more of that reactant. Good. So the same rule, add away for increase. Now, if you go to page 14, we're going to do what happens if we decrease the temperature. Same thing, add away, take towards. So decrease is like taking away or subtracting heat. The reaction is going to shift towards the reaction side containing the heat. So, for example, if we remove heat from the above reaction, which is the same reaction from the other page, remove is like subtracting. So I'm going to put a minus sign under the heat because we're removing heat. And remember, add away, take towards. Now I'm taking away. So that means the new arrow I draw either above or below my old arrow needs to point towards what I took away. Well, I took away heat, so that means my new arrow needs to point towards that, which would be to the right. Since I now have a right shift, that means I'm using up these substances to generate more of the NO and H2O. So I'm using up NH3 and O2 to produce more NO and H2O. So which substances would increase in concentration? It's whatever your new arrow is pointing at, the NO and the H2O. Because we're producing more of that. Now, what's decreasing in concentration would be what the arrow is not pointing at, which is the NH3 and the O2. Those are being used up in order to produce more of the NO and the H2O. So the rules for temperature are the same as the rules for concentration. If you can just remember, add away, take towards. So whatever you add, your new arrow needs to shift away from that. Whatever you remove or take away, the new arrow you draw needs to point towards that. And whatever direction your arrow points, it is pointing at those substances that are increasing in concentration. So those are your first two. The last one we're going to do today is pressure. Now, the rules for the pressure stress are not the same as the concentration and temperature. You can't use add away and take towards anymore. Pressure is only going to affect systems that have gases. So we're going to be looking at the number of moles of gas on each side of the reaction. So you kind of have to put add away, take towards out of your mind right now. We're going to be looking at how pressure affects a system, and it's going to only be dealing with moles of gas on each side. Remember, coefficients tell you the number of moles. That's going to be helpful. So we're going to look at what happens when we increase pressure on a system and when we decrease pressure on a system. So we're going to start at the bottom of page, halfway through page 14. And we're going to look at what happens when we increase the pressure. Think about squeezing something when you're increasing the pressure. So when you increase the pressure on a system, the reaction, you can kind of cross out this line, will shift to the side with the less moles of gas or lower number of moles of gas. This is the side that has more space. So think about it this way. If the room is closing in and getting smaller and smaller, you're going to want to go to where there's less people, right? Meaning more space. So let's take a look at this reaction right here. We've got N2 gas plus 3H2 gas, and then we have our double-sided arrow, and we've got 2NH3 gas. So when we're dealing with pressure, we can't do add away, take toward anymore. We're going to have to count the moles of gas on each side. So if I look on the left, I have a coefficient for nitrogen of 1 and a coefficient for the hydrogen of 3. And both of these are gases. So that's a total of 4 moles of gas on the reactant side. And if I take a look at my product side, I have 2 moles of gas. If I'm increasing the pressure, I want to go to where there's less stuff because I'm being squeezed tighter and tighter and tighter. So that means I'm going to shift to the right because I'm going to shift to where there are less moles. So the arrow is going to shift to the right. Which substances will increase in concentration? Well, a right shift means more reactants are being used up to form more products. And remember that whatever arrow you draw, it points at what is increasing in concentration. So the NH3 increases in concentration. What is decreasing in concentration? Well, whatever the arrow's not pointing at, which would be the N2 and the H2. So when the pressure increases, you shift towards the side with less moles of gas. Be very careful that you check that your substances are gas. If there's no gas involved, you'd say no shift. If the number of moles of gas on each side were the same, you would say no shift. All right, let's look at if you decrease the pressure. And this will be the last thing we do today, decrease the pressure. So think about relieving, you're not squeezing anymore. If you decrease the pressure, the reaction is going to shift to the side with more moles of gas. So that's the side with less space. So let's take a look at our reaction again. Same reaction as above. So we have 4 moles of gas on the left, and we have 2 moles of gas on the right on our product side. If we decrease the pressure, we're not being squeezed as tight anymore. That means we're going to shift to the side with more moles of gas, which is going to be a leftward shift. So I'm shifting to the left. So an increase in pressure, you shift to less moles. A decrease in pressure, you shift to more moles of gas. So let's read what this kind of means. This now means that the NH3 is being used up to generate more of these two, the nitrogen and the hydrogen. So the substances that increase in concentration, it's whatever your new arrow points at. So the N2 and the H2. Which substances decrease in concentration? Whatever your new arrow does not point at. So the NH3. So notice how pressure is different than when we did concentration and temperature. Concentration and temperature, we're add away, take towards. Pressure, you simply count the number of moles of gas on each side of your reaction. And that means you're going to count the coefficients only for gases. If you increase the pressure, you shift to the side with less moles because think about being squeezed tighter and tighter. You want to go where there's less people. If you decrease the pressure, you're going to go to the side with more moles of gas. Remember, the new arrow you draw always points towards those substances that increase in concentration and away from those that decrease in concentration. Tomorrow, we're going to do the last of the stresses. Please make sure you do the skill check for tonight. Please be sure to ask any questions. I know it can be kind of overwhelming. And I will see you all tomorrow.